This video will give you 10 marks in the CBSE board examination. Hello everyone, welcome to Parvathi Tutorials. I am Gururaj, teaching mathematics since 10 years for the young minds like you. Today, let's learn about polynomials. Let's revise this wonderful concept where we use this concept of polynomials in the playground, like an example of throwing a basketball or cricket, or going to the highest level of business and much more. This chapter polynomials is linked with the other chapter of quadratic equations, as you know. This together combined would give us 10 marks of weightage in the board exams. It's very vital for us to know these concepts going forward. So let's start our revision today. Let's begin by knowing the fundamentals of what is a polynomial. With the definition of a polynomial is an algebraic expression in which the power of a variable is a whole number. If you look at the example that we have here, each expression, the variable power is a whole number. Let's look at few. The first one here, you can see the power of the x is 1, which is a whole number. Same way here, the power of x is 2. Likewise, in each of the places you would see that the power of a variable is a whole number, and that is what makes it a polynomial. Now let's look at the other side where it's are not polynomials. I'll give you 3 examples. Can you tell me why are these not polynomials? The first one, as usual by our definition, has a negative exponent. The negative exponent is not a whole number, so that's why it's not a polynomial. In the second one, as we see, although the variable has a power of 2, which is a whole number, but when you write it in the standard form, it is x to the power of minus 2. And that's where the whole number part comes into picture. Minus 2 is an integer, not a whole number. That's where we rule it out. And the last one, square root of x, which can be rewritten as x to the power of 1 by 2, which is a fraction, not a whole number. That's where we discuss that also as a polynomial. Moving on to classifying the polynomials based on the degree. The degree, as we know, is the highest power of the variable. The first one, if the degree is 0, we call it as constant. Here, except 0, if you write any constant, the degree will be 0. Then we move to the concept of linear polynomial, where degree is 1, which we have discussed in grade 9 also. Then we move to the quadratic, which we'll study in detail in this chapter, along with the chapter of quadratic equations. Then we move to the cubic. Quadratic is of degree 2, cubic is of degree 3. Then let's learn about the zeros of the polynomial. Last year we had an idea of zeros of polynomial, which states that any value which would give us the result as 0. Here an example for this, the value of x is minus 5. That is, I substitute the value of x as minus 5, the result would be 0. This year we are looking at a geometrical meaning, that is, what would it visually look like. An example, if you look at the graph of a polynomial, as we can see in the first graph that we have here, on the graph on the left side, as you can see, the graph, what we see here, the U-shaped curve, intersects the x-axis at 2 points. So that is why we say the graph has 2 zeros. And what are those zeros? The zeros are minus 1 and 4. The same way, on the right side, you can see the graph intersect at 3 points. So here the zeros are minus 1, plus 1 and 2. Few more examples for us to understand the idea of zeros. On the left side, the number of zeros are, can you make a guess? It is no zeros, because the graph doesn't touch the x-axis at all. But on the right side, you see the graph touches the x-axis at only 1 point, so the number of zeros is only 1, which is 2. Move on to the idea of how we can find the zeros with the calculation. As we have learned in our grade 8 about grade 8 and 9 on the method of splitting the middle term, we shall use this. So let's learn the basic form of a quadratic polynomial, which is ax square plus bx plus c, where the initial condition of a not being equal to 0 and a, b, c can be any real number. So the graph of this, what we saw, a U-shaped curve, is called a parabola. The graph open upwards if the a value is positive, and the graph will open downward if the value of a is negative. As we can see, one is a smile and one is a frown. Moving on to finding out zeros, as we mentioned earlier. The first one will equate the given quadratic polynomial to 0. Then we multiply the first and last term to get 6x squared. And we look for the middle term, which is 5x. Now comes our testing part. we do trial and error. We look for two factors which on multiplying should give me 6x square and on addition should give me 5x. So can you guess what those are? Yes, that is exactly 2x and 3x. So we split our middle term 5x into 3x and 2x and the rest as it is. Now we take common the first two terms and the next two terms. We are basically splitting the four terms into the first two and the next two. We take common, we would be getting x into x plus 3 and 2 into x plus 3. Here we take common again, we see that x plus 3 is the common factor again among the two terms that we have. We take that out, we are left with the two factors x plus 3 into x plus 2, which on equating it to 0, we get two values of x. The first one is x is equal to minus 3, second one x is equal to minus 2, which we shall name it as alpha and beta for our convenience. Moving on to how we can relate the question to an answer. That is how we can relate these zeros to the coefficients. We have two relations. The first relation is alpha plus beta is equal to minus b by a, where alpha and beta are the zeros, and b is the coefficient of x, and a is the coefficient of x square. And then the second relation, alpha into beta is equal to c by a, where c is the constant term. Let's see how we can use this to verify. So the same question, x square plus 5x plus 6, where a value is 1, b is 5 and c is 6. By factorizing, we got the zeros as minus 3 and minus 2. So let's look at what is alpha plus beta. Add the zeros, minus 3 and minus 2 would give us minus 5. And minus b by a on the other side, negative of b, that is negative of 5 by 1 would give us minus 5. Here we see that minus 5 on the left side, minus 5 on the right side. So we can conclude that alpha plus beta is equal to minus b by a. Same way on the other relation, alpha into beta, we multiply the zeros, we get 6, and we divide c by a to also get 6. So we conclude that alpha into beta is equal to c by a. Moving on, let's see how we can work our way backwards. That is, if we start from an answer, how do we get the question back? That is, if you know the zeros, how do we write the polynomial itself? Now, if you know that x is equal to alpha, that is, if you know the zeros of the polynomial, we can write a polynomial using the relation x square minus alpha plus beta into x plus alpha into beta multiplied by a factor called k, where k is any real number. So this commonly written as x square minus sum of zeros into x plus product into k. Sum and product are generally written in the cases where alpha and beta are not zeros. As we have come across in many questions, the zeros would change. Not just alpha and beta, the zeros would be alpha plus 2, beta plus 2, 3 alpha, 3 beta and so on. So generally we would stick with the notation sum of zeros and product of the zeros. Now let's simply revisit on why do we need the value of k here. As we understand, these are with the graph that you can see on screen. There are different polynomials we have, and all these set of polynomials have the same set of zeros. As you can notice here, 2 and 3 are the zeros, and these are different polynomials that we have. So a polynomial and its multiple will have same set of zeros. So for given zeros 2 and 3, there can be infinite number of answers that we can have. So that is where we introduce the concept of k, the multiplying factor. And lastly, let's see a few examples that to form a polynomial. Suppose the zeros are 1 by 4 and minus 1. We substitute, we find the sum. Once we find the sum, we get x square plus 3 by 4x minus 1 by 4. This is a polynomial, one of the polynomial among the infinite possibilities. To write this polynomial in a simplified form, we will choose the value of k to be 4 and simplify this further to get 4x square plus 3x minus 1. Then few questions we generally come across in board exam about alpha and beta. The first one is finding out alpha square plus beta square, which is alpha plus beta whole square minus 2 alpha beta. This is traditionally your a plus b whole square formula modified. Then we have alpha inverse plus beta inverse, which is 1 by alpha plus 1 by beta, which on taking LCM would give us alpha plus beta by alpha beta. Then the last one, alpha minus beta, which is equal to plus or minus square root of alpha plus beta whole square minus 4 alpha beta. So here, this is the formula which we get by modifying or combining a plus b whole square and a minus b whole square. And the plus and minus here we have is because of the alpha and beta can be interchanged. Depending upon which is greater, we'll be thinking of whether the answer is positive or it is negative. So this summarizes the entire chapter of polynomials, which is a build-up for a quadratic equation that we have in the coming time. Now let's see a few examples on using alpha and beta to solve certain problems. So here I have on my screen the polynomial x square minus 2x plus 3, which is non-factorizable. So let's look at how we can find the values of alpha square plus beta square first. Okay. So here we have the value of a to be 1, the value of b to be minus 2, and the value of c to be 3. Now let's find out alpha plus beta. As we know, alpha plus beta is negative b by a, which is minus of minus 2 by 1, which would give us 2. Likewise, alpha into beta is c by a, which is 3 by 1, that would give us 3. Now, as we learnt the formula, alpha square plus beta square, which is equal to alpha plus beta whole square minus 2 alpha beta. So we have alpha plus beta is 2, 2 square minus 2 into 3, which is 4 minus 6, which is equal to negative 2. I have a pro tip for you. One common mistake what most students do is, whenever they encounter questions like this, an example here we have x square minus 3x minus 2, most students start by splitting a middle term, which is where we go wrong. Most of the questions like this can't be done that way. What's an easier option, you ask? Let me tell you. Let's start by doing what we have, the sum of zeros. Let's start from the relation alpha plus beta and alpha into beta. So we have alpha plus beta is equal to 3 here, and alpha into beta is equal to negative 2. So in this case, they have asked us to find a polynomial whose zeros are 1 by p and 1 by q. So for a new polynomial that I have, the sum of zeros would be 1 by p plus 1 by q, which in turn is p plus q by pq, as we have learned earlier. So which would give us negative 3 by 2. The same way, when you look at its product, this would be 1 by p into 1 by q, which is 1 by pq, which we can simplify it as 1 by 2, that is negative 1 by 2. Now, to write a polynomial, the new polynomial p of x, we can write this as x square minus, as we know, the sum of zeros into x and the product. Entire thing we will choose a multiplying factor here 2. So as we multiply this, we get 2x square plus 3x minus 1. The same problem, if we try factorizing and solving, it would be a whole lot lengthy. Instead, sticking to the process of alpha plus beta and alpha into beta would be a lot simpler. As we understand here, every problem here can be brought down to in terms of alpha plus beta and alpha into beta, the only two formulas that we have. This works in the chapter of polynomials as well as in quadratic equations. So, thank you so much.